How about we go through the announcements for today? Homework 2 is due tonight on WebAssign. If you're having trouble with the graphing problem, please ask me for help. And I have another announcement for homework 2. I'm not going to be grading 14, 15, or 16. These questions ask you for like a different form of an equation, which I haven't really taught you. I don't even think it's very important to know that form of the equation. So I just won't be grading those. So if you don't answer them, I'll just add points to your score, kind of like last over. Okay, quiz 4 is today. This will be covering, I guess, lines, the distance formula, things like that, kind of like our quiz review last week or on Wednesday. And we have a test coming up. Next Friday is our first test. There is extra credit available on my classes, so make sure you turn that in before the test. And I guess before I forget, I have a test review for you guys. So study guide, I also put on my classes. Okay, so it's very long. Don't freak out because the test won't be as long as the questions on here. I haven't made the test. I don't know how many questions are actually going to be on it, but I can assure you won't be that long. So let's kind of just take a look at this review. Let's see. The very first page is kind of a list of topics that might be on the test. So, for example, solving linear equations might be on the test, right? So everything on the first page is anything that's game for the test if you kind of want a list of topics to check through when you're studying. If you kind of want to go through more examples of questions, I've put a little practice exam at the back. So very much longer than an actual exam, but I put some of the more important questions that I might ask you, some of the topics that we've done in more detail than the other ones. Okay. So any questions on the test, homework, quiz, anything like that?
How long, like, what chapters are going to be on the test?
Yeah, so if you take a look, it's going to be chapter 1, 2, and 3 up until finding the domain and range. Mm-hmm.
Oh,
yeah.
So this week, like it was like all up to this week, or
I think it'll be so Monday. Also, stuff we cover Monday and Tuesday might be on the test. So everything up until the domain and range of like 1 over x functions. Okay, I won't test you on something I haven't taught you, so don't worry about that. Stuff we do on Wednesday is going to be review. So I guess the cutoff is next Tuesday. Okay. Any other questions on the test? All right. Okay, so why don't we do this? Let's kind of switch gears into our first topic of the day, which is continuing lines. Let's try to just go through what we've done so far. We've talked about lines, which are very important because they're kind of the backbone of this thing called calculus. The idea of slope or how steep something is very important when you put it into perspective of like actual things that happen in real life. And we've talked about making an equation of a line, which is kind of like code for the picture, right? So in order to find the equation, we had this thing called slope, where we had a formula y2 minus y1 over x2 minus x1, okay? And we use slope to draw a line if we're given a point, right? We also talked about horizontal and vertical lines. We've talked about how to sketch a line on a graph if we know the slope and a point. And we also talked about this thing called slope-intercept form, which is y equals mx plus b, where m is the slope, b is the y-intercept, okay? And this form is really helpful when we're trying to find the equation of a line, especially when we're given 2 points. So in this example, we were given a point A and B, and first we found the slope, and then we used one of the points to find the whole equation of the line. So the y-intercept, right? Okay, so we did a bunch of that stuff. Then we started talking about this thing called parallel lines. So 2 lines are parallel if you can extend them forever and they will never intersect. So two lines that kind of run like on the same page as the other, right? They follow each other, kind of like lines on a road. Okay, and we talked about how two lines are parallel if they happen to have the same slope. Okay, so in example 7, we found the equation of a line through 5, -7, and it's parallel to the old equation, which is 6x plus 3y equals 4. Okay, so to find the slope of our new line, we first had to take the old equation and put it into slope-intercept form. Okay, and since the slope of the old line was -2, the new line also had a slope of -2 because they were parallel, right? Okay, so finally we took the slope -2 and the point that we were given in the question, plugged that into slope-intercept form and found the y-intercept of the new line. And finally, our new equation was using our new slope and our new y-intercept. Okay, so how confident are you guys in trying example 8 on your own? Okay, how about this? I like the confidence. Let's try example 8. I'll put example 7 up here so you have it, and I'll be around to.
Pew pew pew! Yo, listen up, here's a story about a little guy that lives in a blue world. And all day and all night, and everything he sees is just blue, like him, inside and outside. Blue his house with a blue little window and a blue Corvette. And everything is blue for him and himself and everybody around, 'cause he ain't got nobody to listen to. I'm blue, dabba dee dabba die, 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 dabba dee dabba die.
Well, this. Why don't we come back to the front here? Okay, example 8. We have a very similar equation to the last one, old equation, and we want to find the line that also passes through 4,3, but is also parallel to the old line. Sam, do you kind of want to take us through your steps?
Yeah. So you have to get it into the correct form
Mhm.
first. So you add 3 to both sides so that the y is on top.
Mhm.
Now we know that the number of x is the slope, so -5.
Mhm.
And then we have the point that we're given, which is 4, 3. So
Mhm.
we plug all those into the y equals mx plus b equation.
Mhm.
And then we simplify it down so that b is alone. It's 23. And then put that 23 into.
Awesome, awesome. So our new equation is -5x plus 23. Okay. Any questions on example 8 and how we got to our final answer there? All right. Okay, so we're going to talk about a very similar topic, okay? But instead of parallel lines, we're going to talk about something called perpendicular lines, okay? So let me just give you an example here. We know that parallel lines can like run kind of next to each other and never intersect, right? Now I'm going to show you what a perpendicular line is. I'm going to take this line, okay? And I'm going to do this. I'm going to kind of flip it around like that, okay? And make sure that it is kind of intersecting this line at a 90-degree angle, okay? So basically, I've taken that line and made sure that all the corners that it makes when it intersects ends up being 90 degrees, okay? So intersects at a 90-degree angle. Okay, so one thing I want you to notice about perpendicular lines is that if one of the lines, so the original line, if it's decreasing, then the line that's perpendicular to it has to be increasing, right? And if the original line is increasing, the perpendicular line has to be decreasing. So they have to be like the negative slopes of each other. Does that make sense? Okay, also the slope has a very particular formula. We actually call it the reciprocal, okay? And I actually forgot to say one thing on these notes. So on your notes, I want you to write after the word the, I want you to write negative. Okay, so two non-vertical lines are perpendicular if and only if their slopes are the negative reciprocals of each other, okay? So I think we all know what negative is, but reciprocal is a little weird, right? Let's kind of go over what that word means, okay? So how about this? Reciprocals. Okay, you might remember this from, I don't know, maybe in high school when we talked about fractions, but let me just give you an example of something that is a reciprocal, okay? Oh, negative reciprocal, sorry. Negative reciprocals. I actually really like that word. I like saying it. Okay, so I'm going to give you a fraction, 3/2. Anyone remember what the negative or reciprocal is? Yes. Negative 2/3. Good. So I guess the word reciprocal means take the denominator and put it in the numerator, and take the numerator and put it in the denominator. So we're like kind of swapping the fraction around, okay? The negative part is just changing the sign, right? So the negative reciprocal of 3/2 is negative 2/3, okay? And it also goes the other way. The negative reciprocal of negative 2/3 is 3/2, okay? Let me give you another example. How about -2? What would the negative reciprocal of -2 be? +2, but you have to do something with the fraction. Yeah, 1/2, right? And if you don't see that, what you can do is kind of imagine that -2 is -2/1, and then you can kind of see how flipping the fraction over kind of makes it a half, right? Do you see that? Okay, let's just do another example here. I don't know, -1/8. What's the negative reciprocal of -1/8? 8, right? 8/1 or just 8, right? So I think we're all good on what a reciprocal is, what a negative reciprocal is. We just flip the sign and then kind of swap the numerator and the denominator. Okay. So let's take a look at example 9. Let's put this into perspective here. So we are asked to find an equation of the line that's perpendicular to this old equation, okay? And it also passes through this new point, okay? So we are going to do the same thing that we did with the last equation with parallel lines, but we're going to do a little extra step at a specific point, okay? So let's still start with our old equation. 6x plus 3y equals 4, okay? What's my first step into getting this into slope-intercept form? Good, subtract 6x, right? Okay, so I get 3y on the left, and then -6x plus 4 on the right. Okay. What's my next step? Good, divide by 3. So on the left, I get y, and on the right, I get -6x plus 4 over 3. Okay. Is that in slope-intercept form though? No, how would I get it in slope-intercept form? Yeah, split up the fraction and make 2 fractions, right? Since I have addition in the numerator, okay, we can split up the numerator into 2 fractions, both over 3. Okay, can't do it if it's in the denominator though. 6x over 3 plus 4 over 3. Okay. This is fine, but does anyone see how we can simplify this even more? Yeah, divide 6 by 3 and get -2, right? Y equals -2x plus 4/3. Okay, so we've gotten there. Remember that this is still the old equation, right? So this is our old equation. This is not the new one that we want to find. And let's just write this out. The slope of the old equation. So what's the slope of the equation I just found? -2, good. Okay, so I kind of like writing things out just so I don't get confused. Let me write this. Slope of the new equation. What would this slope be? Yeah, I heard it. +1/2, right? So it's the negative reciprocal of -2, since we're finding a perpendicular line here. Okay. Okay, so any questions on what I've done so far? Okay, so we found, let me kind of like draw a line here. We found the slope of the new equation, so we know that m is 1/2, okay? And we know that the point is 5, -7, just from the question that we were given, okay? So we have m, we have an x value, we have a y value. All we have to do is kind of do the same thing as our last example, right? We take y equals mx plus b. We plug in our y value, -7. We plug in m. We plug in 5. And now I guess we're just solving for b, right? Okay. So 5 times 1/2 is, I don't know, 5/2. I'm going to cheat, 2.5. Okay. And to solve for b, I guess we subtract 2.5 on both sides. And I'm getting -9.5 equals b. Okay. So, okay, now we can finally construct our final equation, right? Y equals mx plus b. So y equals m, which is 1/2, times x, minus b, which is 9.5. Okay. So this is our final answer. It does kind of look weird because we have a fraction and a decimal. If you want to, you can convert 9.5 into a fraction, but I don't trust myself to do that in my head. So if you want to do that in your calculator, totally fine. Okay. So any questions on any of the processes that I've done here? All right. Well, I think that kind of caps off our section 3.3 on lines. Let's kind of switch focus into our next section. We have a new set of guided notes, which I will pass out. This is like the last thing that's being for the test. I do have my squishy earrings, so that's because I forgot to bring it for the first one. We'll play Kahoot sometime. All right, and now I have to, this is my last class. Okay. So does everyone have a pair of guided notes now? Okay. So we're talking about the definition of a function. I feel like the idea of a function is pretty easy to most people, but later on in this section, we're going to start talking about domain and range, which I feel like scares everyone when they see it. But I promise you, it's not as bad as you think. We'll go through it. I think you'll find it to be a little bit easier than you might remember. Okay. So what is a function, right? This big word that we keep throwing around, but we don't actually have a definition yet. Okay. Let's kind of just go through what this definition says, what it means, and how to determine if something's a function or not a function, okay? So a function is a mathematical rule, okay? I don't really like the word rule. I feel like it doesn't really give much insight into what's actually going on. I kind of prefer the word relationship or maybe connection, right? Something that we can put into perspective, right? Like height and weight, or the temperature outside and your heating bill, or maybe the time of day and how hungry you are, something that goes hand in hand with each other, okay? And it's a relationship that takes in inputs, and we know that inputs are like X values, right? And it produces outputs, okay, Y values, okay? But it's even more special than taking in inputs and producing an output, okay? it says that for each input or an X value, we produce exactly one output for the X value, okay? So for one X value, we get one Y value. Okay, so if that doesn't make sense, we'll go through a few examples, go through the word definition, and if you're still confused, we have a nice test that kind of pieces everything together. Okay, so example 1, y equals 2x minus 3, equation of a line. We are very good with lines now. How about this? Let's take an input. So this color doesn't work here. Okay, X values are input. Everything on the X values are things we can plug into the equation. Okay, so let's just take, I don't know, X equals 1, or sorry, X equals 0 as our input. What would our output be? Yeah, -3, right? So if X is 0, Y is -3, right? So that's kind of what our function or equation is telling us. Input, output. Same thing, like X equals 1, outputs like -1, okay? X equals 2, outputs 1, right? So input, output, okay? Is there any place on this graph where one input gives me more than one output? No, right? Every single input gives exactly one output on the line, right? There's no way I can get two outputs, like, I don't know, an output here and an output there, right? Because we just have a straight line going across, okay? So this is an example of something that is a function, okay? Let me give you another example of a function, okay? Y equals x squared. Okay, this is a function because I guess it's the same thing. For every input, like x equals 1, I'm only going to get one output, y equals 1, right? Sorry, that was -1. Okay, if my input is 2, my output's going to be 4. There's no two outputs coming out of one input. Okay, so this is another example of a function. Okay, usually these things called polynomials where we have an output and then like our inputs like x squared plus 2x plus 5 or something like that. All these are going to be functions because we just have a line that doesn't like double back on itself. Okay, let me give you an example of something that isn't a function. Okay, so this is not a function. Okay, and I'll show you why. Okay, let's take, I don't know, x equals 1. Okay, our input. Okay, input's 1. How many outputs do I have? 2, right? I have this one and this one, right? So for one input, I'm getting 2 outputs, which is against our definition of a function, right? So this is not a function because we have 2 outputs for one input. Okay. Let's go to example 4. We've talked briefly about circles. I have an example of one. This is actually called the unit circle because the radius is 1. Okay. And let's look at this. I don't know. Is there any place on the circle where one input gives one output? Anyone see it? Not the center because we get 2 outputs here, right? What about, I don't know, x equals -1? Yeah, we get 1 output there and 1 output there, okay? But for the definition of a function, that doesn't really matter, right? Because there is a point like x equals 0 where we have 2 outputs. I don't know, x equals -0.5, we still have 2 outputs. So because at one specific point, we have 2 outputs for one input, this is also not a function. Okay. So, I mean, if you're comfortable with looking at the definition and determining that there's 2 outputs for one input, that is totally fine. Go ahead and do that, okay? But let me give you an easier way to do this, okay? So let me take a look at my 4 graphs. I'm actually going to draw a big vertical line here, okay? And I'm even going to take a lasso and drag it, okay? So let's start with example 1. I'm going to take this vertical line and just drag it from left to right, okay? So it's going from left to right, right? Like kind of like that, okay? Is there any point on this vertical line where the graph hits the line more than once? No, right? Over here, I only hit the graph one time as I move it from left to right, right? Okay, let's go to example 2. Hitting the graph, but only at one point, right? So only at one point am I ever hitting the graph of the function, right? Okay, let's go to example 3. Now, when I hit here, my vertical line is hitting the graph at 2 points, right? Which is not allowed, right? So if my vertical line touches 2 points as I move it from left to right, I don't have a function. Does everyone kind of see that? Okay, example 4, vertical line, we get here, oh, there's 2 points hitting the line, oh, that's not good, so we don't have a function, okay? This is called the vertical line test, okay? So if we take this vertical line, move it from left to right across the graph, and we hit the graph in more than 1 point, okay, we don't have a function, okay? Anything else is totally fine. Okay. Any questions on vertical line tests, determining if something's a function or not a function? All right. Okay, so we kind of talked about lines and quadratic functions where we know that we have a function because it's just like a straight line going from left to right, right? Or it's a parabola going from left to right. Those are definitely functions, right? So here's another example of a line, which is definitely a function. And taking a look at this, it's pretty obvious that x is our input and y is our output, right? Usually when we graph lines, x is the input, y is the output, okay? And since this is a function, I'm gonna write how we can say this in words, okay? What we usually say is that y is a function of x. Okay, that's kind of the way that we say this. So we have a function, y is the output, x is the input, y is a function of x, okay? If you don't want to write all of that out every single time, okay, you don't have to write this specific phrase down, but sometimes we kind of write it like this. Y is a function of x, okay? So sometimes we use this. This notation isn't used that often because we still use y and x, right? Let me give you something that's used a little bit more often. How about this? F of x equals 3x minus 1. Okay, so this is saying we have a function of x, which we call f, okay, and it equals 3x minus 1. Okay, so the way that we read this is the input is everything inside the parentheses. Okay, and f of x is the output. Okay, so anything in the parentheses goes inside the input. Everything that results on the right-hand side or the left-hand side is the output. Okay. Now we don't necessarily have to use that notation. Or x as our input. Anything that goes in the parentheses becomes our input. So for example, I could do this, f of a. What do you think would be on the right-hand side? Not 3x, but 3a minus 1. Good, good. 3a minus 1. Okay, so do you kind of see how this is going here? Anything in the parentheses goes in the input, right? So it doesn't have to be x. It can be a. It could be b. 3b minus 1. Okay, it could even be, I don't know, smiley face. Okay, if smiley face the input, what do you think is the output? Yeah, 3 smiley face minus 1, right? So anything inside that parentheses is the input of our equation, okay? We can even do this. How about this? F of negative 1. What would this produce? Good, 3 times negative 1 minus 1, because our input isn't a variable anymore, it's a number, right? So this becomes 3 times -1 minus 1, which is -3 minus 1, which is, I guess, -4, right? Okay, we can plug in any number, right? We can plug in 10,000 in our input and it would still produce an output, okay? And we don't have to put one variable if we don't want to. We could even put this, f of a plus b. What do you think this would produce?
3a plus b.
3a plus b minus 1, right? So all we're doing is sticking the input or sticking the thing in the parentheses into the input of the equation, okay? I guess we can simplify this. Distribute that 3a plus 3b minus 1, right, would be our output, okay? How about this one? I don't know. F of x squared. What would that produce? So x squared is now our input. Good, 3 times x squared minus 1, or I guess more simply, 3x squared minus 1. So we're just sticking it in the x spot, right? Okay, how about this one? F of negative x. What would this be? Sorry. sorry. I'm going really fast, so sorry. Okay, how about this? F of negative x. Go slower. Oh, I heard it. Negative 3x, good. Or we could say 3 times negative x minus 1. Okay. So 3 times negative x is negative 3x minus 1. Okay, I'm sorry, I went really fast because I got really excited, but I'm gonna put this on the screen so you have time to write it down, okay? Anything we put in the parentheses turns into our input, so we just stick it in place of x. Okay, any questions on the notation? We will go over this on Monday too, so if I went too fast, I promise we will get to it. Okay, but any questions so far? Okay, how about this? It's quiz time.